Hey, sorry, interviews. The next question, calculate the value of k at 373k. So in this case, interesting. So in this case, red. Yeah, in this case, we have the activation energy from the question. Now you're calculating k, but you have an under new temperature. Now, in this case, come on. What happened to my camera? Awesome. So what happened? All right. So in this question, sorry for the interruption. We have temperature, we have activation energy, we have K. Now we're looking for K. Now the thing is that in order for this to work, we need to have the A, right? We need to have the Arrhenius constant. Earlier, we actually did that already. In our earlier question, we actually calculated A as this value. And this is actually a constant value. So in this case, we can use the same one from the previous one. So it's 0. And as you know, you always carry a lot the digits while you're in the middle of calculation. So looking at the handout, you will use, because you're looking for k, you'll use the other formula. So in this case, you'll use ln k equals small k, by the way, equals ln a minus activation energy over RT. So come back here. So ln k. So in this case, we just really, again, plug in numbers. So ln a 968 times 10 to the power minus 4 minus activation energy is 102. R is 8.31 and T is 373. So in this case, okay, ln of 0. Now I'm going to just convert this into minus 4. So, oh, you have already minus, right? So 0.0005968 equals, in this case, you have minus 7.42392 minus 102 divided by bracket 8.31 times 373. In this case, 0.032907. So in this case, you add these, or you kind of put these two numbers together, minus 7.42392. That gives you minus 7.3910. Now keep in mind, or maybe let's just say 128, okay? So keep in mind this is ln k. To find k, you actually have to do the reverse of that. So in this case, you put the reverse of that, which means k would be e to the power of minus 7.391028. Oops, 10128. So what you do is shift E. Now, minus 7.391028 equals, so right now K I have on the calculator, and as you can see, 6.167709 times 10 to the power minus 4. So if you look at what we had in the previous question where k, it's also a 10 to the minus 4 number, this is actually pretty reasonable, okay? So that's why I have, and if we want to go through sig figs, you have 3 sig figs, 3 sig figs. So technically, you let's just say have 3 sig figs wise, then it will be 6.17 times 10 to the power minus 4. Okay, so that's what I have for B. That's a value for that. Now, what's my next interview? Okay, I still have a little time. So now, question number C: determine the absolute temperature. Determine the absolute temperature when, or K, or temperature, when K is 2.66 times 10 to the power minus 4 per second. So a lot of the values are also the same as before. So in this case, activation energy is still 102.102 kilojoules per mole. Your A is still the same before, 5.00968. Let's use this value. And you are looking for temperature in Kelvin. So this you will have to use this equation here. So I'm going to copy it down. T equals minus activation energy R times ln K minus ln A. So that's a formula. This formula. So that's the equation I will have to use. I plug in the equation. Minus 102. R is 8.31. Now, ln of 2.66 times 10 to the power minus 4 minus ln A. Now, personally, I haven't done use ln for a while or doing these kind of manipulation in a while. Is there a way to kind of, I don't know, factor this? I don't remember. But in regards, either way, let's just plug in the numbers in our calculator. So ln of 0.123266 equals, so I have here minus 102, 8.31. So I have minus 8.232014 minus, carry a lot of digits, so ln 0.1235000968. So in this case, now keep in mind, this is minus another minus number. So in this case, I'm just gonna, for clarity's sake, I'm just gonna write everything out. 8. Okay. Yeah. So in this case, minus and minus is really a plus, but it's plus to a negative number. So in this case, what I'm just going to do is 0.232014, and then just put a minus sign in front of it because I know that this is minus 8. This is plus 7 point something. It's going to be bigger. So it will be minus 0.633045.6. Let's leave it at that. Minus 102. Now, minus and minus, we might as well get rid of it just to make the calculator work a lot easier. So, plugging in numbers. 2 divided by bracket 8.31 times 0.633045.6. Syntax error. Interesting. So 102 divided by bracket 8.31 times 0.666330456 close bracket. All right, so it is, that makes sense, 19.38939, and that's the temperature in Kelvin. So that's T. That's temperature in Kelvin. Now, if we look at the other values, does it make sense? Well, when you have 318 Kelvin, you have 4.18. This is half of that value, but yeah, my calculator work looks right. Yeah, yeah, my calculator work looks right. So now, unless I made a silly mistake, this seems to be the right answer, 19.38. So that's degrees Kelvin. Let's round it to three sig figs again. So it'll be zero point 0.4 Kelvin. Okay? So in a few minutes from my next appointment. So just in case I don't get to finish, at least now I have B and C on. Okay, I'm gonna try to get the other one done a little bit later.